All right, gang, today we're going to do one more day of transforming functions. All right, so we have the equation f of x equals x squared minus 8x plus 12. So let's start by pulling up that table and graphing it on the coordinate plane. So we go to y equals, we have x squared minus 8x plus 12, and we pull that equation up, and we find the vertex, which looks to be at 4, negative 4. You see where the turning point is there. So let's graph from 0, 12 to 8, 12. So we get the same amount of points. 0, 12 is 2, 4, 6, 8, 10, 12 here. Then 1, 5. Then 2, 0. Then 3, negative 3. Then 4, negative 4. And then the same points on the opposite side, bringing us to 8, 12. Okay, again, we're going to draw the whole thing because we weren't given a specific domain to graph it over. Arrows on both ends, label it with f of x. So now it says to graph g of x and determine the function rule for g of x using that formula. Graph it on the same grid and see how f of x changed to get g of x. So because it says it's f of x minus 2, wherever there's an x in f of x, we're going to replace it with x minus 2 in parentheses. So g of x is x minus 2 all squared minus 8 times x minus 2 plus 12. And we don't have to put that in standard form unless it asks us to. That is fine. We can put that right in our calculator and pull up the graph or the table that goes along with it. So we're going to clear what's there, put in parentheses, x minus 2 all squared plus, minus 8x minus 2, then plus 12. So it should look exactly like that in your calculator. We pull up that table and look for the new vertex, which again is down at negative 4, but at 6, negative 4. So we're going to graph from 2, 12 to 10, 12, with 6, negative 4 being our vertex. So I'm going to start at 6, negative 4 and then build around that. So 6, negative 4 is here. Then we have 5, negative 3, and 7, negative 3 would be here. Then we have 4, 0, and 8, 0 would be here. And then we have 9, 5, and 3, 5 is here. And last 10, 12, and 2, 12 being here. So the shape of this quadratic function is exactly the same as f of x. And if you're looking at it really closely, you can tell that the only thing that changed is that all the points were shifted over 2. So this went over 2, then that purple one went over 2, this purple one went over 2, this purple one went over 2, this purple one went over 2. Same here, same here, same here, and same here. So by replacing all the x's with x minus 2, we've shifted f of x 2 units to the right to get g of x. And if you remember when we were talking about the transformations, this is kind of like the h value, which gives us the horizontal shift. So since we're going x minus h, that means we're going to go h units to the right. If it was plus h, then it would be h units to the left. It's the opposite of the sign. All right, so let's take a look at our next example. In this case, we're starting with negative 3x squared minus 5. So we go back to our y equals, we clear what's there. Negative 3x squared minus 5. Always remember that for a minus sign, you're using a minus, not a negative. Pull up the table and look for the vertex. So I see the vertex here at 0, negative 5. So we're going to start there and then build around it. 0, negative 5 is here. Then we have negative 1, negative 8, and positive 1, negative 8. And negative 2, negative 17, and positive 2, negative 17. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 would be here, and then here. So this is a negative graph, so our vertex is a maximum point, and it's super narrow because of the 3 on the outside of the x squared. And we'll label that f of x. So now the next part says to apply h of x, and h of x is negative f of x minus 20. So we're going to negate all of our f of x, and then we're going to subtract 20 in the end. So again, I could leave it or I could distribute the negative and rewrite the function, but we can easily put that into our calculator as well. So we clear this, and now we have negative, parentheses, negative 3x squared minus 5, close the parentheses, then minus 20. Pull up that new table. And now we have a vertex at 0, negative 15, and we can build from that. So remember this bottom point was negative 18, so that would mean, or negative 17 rather. So this point here would have to be 15. Let me just check. This was at 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. So that's our 0, negative 15. It's now a minimum vertex because we're going to go up negative 112 and positive 112. And then negative 2, negative 3, and 2, negative 3 is right there. And that's probably all I'm going to be able to fit because I can't get the 12 on there. So I'm going to regraph this one through those points. Looks like this, and we're going to label that h of x. Okay, so determine the function rule. We did that. Graph it on the same grid. We did that. How did the graph of f of x change to get h of x? So now we should notice some things from our transformation. So here we have a negative sign. Whenever you have that negative sign, it means there's some kind of reflection. So it reflected over the x-axis. Let's start with, whoa. Oh, I see what happened. Okay, so h or f of x reflected over the x-axis, which is hard to envision, but if you think of that blue line flipping up over the x-axis, that means its vertex would now be a minimum, and it would be at 0, positive 5 instead of 0, negative 5. And then it was translated, and we know it has to be a vertical translation because this is outside of the parentheses, and it's minus 20, so it should be down 20. Now, some kids want to count directly from the top of my blue to the bottom of my purple, but that wouldn't make sense, or the bottom of the purple to the top of my blue. But if, again, you think about, okay, that purple one, or the blue one rather, being flipped up over the x-axis, that would be at positive 5. And then positive 5 minus 20 would bring me down to my new vertex at negative 15. All right, so it's all about seeing those transformations over the axes and thinking about how it's been shifted according to the equation. All right, so hopefully you saw those because you're going to be on your own. You're going to complete number 5 and number 6. Your hint is to put the original function in brackets, multiply the entire function by 1/2, replace all x's with x plus 1 in parentheses, and negative 3 at the end of the function outside the brackets. Okay, so there's a lot going on with this one. Take your time, think it through. I'll be around to help you guys out.